All right, what we have now is a pretty excellent explanation of the second fundamental theorem of calculus. That's really what this everyone calls this, the second fundamental theorem. So let's take a look here. This is pretty cool. Now, so the question here is, and I know there's a lot of notation here, but as we saw on that second fundamental theorem earlier, it was pretty much that the derivative and integral cancel each other out. Well, that's true for the most part. But earlier we traveled from our lower bound was just a number, and our upper bound was x. And so indeed it was f of x. Now the question is then, what if you change that to something other than x? Well, we've seen that before. It's called chain rule. All right, but let's see how that applies here. Because we are taking the derivative, and we are taking the derivative of something that eventually will have more than x. Okay, so that would be a good way to explain why you need chain rule on this, but let's show it with an actual example. She's got these two switched here. That's fine. The upper bound is x. Okay, so these two need to be switched. And the lower bound is a constant. Okay, that's fine. Okay, now, so here we go. So let's do a couple of things here. So the question is, will it always be that little f of x is equal to big F prime of x? That's the question. All right, so we're going to find out. Now, the first one, it's going to work out really, really nice. So if we take the antiderivative and we do the first fundamental theorem, then the antiderivative is sine. So this will be sine of t, okay, because that's our variable that we're doing here, right? And we want to evaluate that from pi to x. All right, so the first fundamental theorem says you substitute in your upper bound, so this will equal, okay, sine x minus sine pi. Cool. So that's big F of x. That's for this particular one. All right. Now, secondly, then we're to take the derivative. We want to see what f prime of big F prime of x would be. So a big F prime of x would be, okay, the derivative of sine, which is cosine, but now we've switched to x, minus the derivative of a constant. I mean, what sine pi is 0, but anyway, but the derivative of that's still going to be 0. So, but I'll just go ahead and put that right there. So this is equal to cosine x. Okay. Ooh. All right. Well, so then, what if we just said, okay, well, we just take the derivative of that in terms of x. All right. So the derivative of this was so what we just did here was big F and then F prime, right? So, but the question is, would that be equal to just cosine with this x substituted in? It absolutely is. All right. So in this case, it is. So in this case, F prime of x, big F prime of x, right, was exactly the same as f of x. Okay, which is pretty much what the second fundamental theorem said. All right, but hold your horses. All right, let's do this one right here. Okay, so on this one right here, if we do the whole process again, we're now traveling, our lower bound's a constant, very nice, 0, and our upper bound is in terms of x, but it's not x. Okay, so let's see what happens on this one. All right, so if we do the first fundamental theorem, then big F prime of x. No, sorry, that's too early. Okay, sorry. Big F of x. Let's go blue here. All right, so big F of x will equal, and now we're just performing like we did before. We're doing the first fundamental theorem of calculus. Okay, I could rewrite that as 1 plus t to the 1/2, right? So here we go. So I'm doing the antiderivative, all right, which will be all right. So it'll be 1 plus t to my new exponent. So it was 1/2, so now it's 3/2. Good. And divide by the same. And we're going to evaluate that from 0 to x cubed. Okay. All right. And so, all right, so let's do that. All right, so we're going to substitute in. And so we're going to have 2/3 1 plus x cubed to the 3/2 minus 2/3 and then 1 plus 0 cubed. No, 1 plus 0, just 0. To the 3/2. Cool. Which all that's just a number. All right, and so then, and I got writer's cramp like you wouldn't believe. Okay, so now what it says now is take the derivative of that. We want f prime. All right, so let's say, so here we go. So f prime then of x, okay, would be, do your power rule, okay, 2/3 and 3/2 cancel each other out. All right, and then I'll have, so they just cancel each other out, the exponent and that coefficient. So I'll have 1 plus x cubed to the 1/2. But hold on, we need chain rule. All right, and so chain rule then would be times 3x squared. That's the derivative of the inside part. Chain rule same chain rule that we've done a million times. And then minus 0. Because all of that's a constant. And so all of that is gone. So that's why on these, it doesn't matter what your lower limit is or upper limit if you want to flip them around. It doesn't matter if it's a constant. It doesn't matter what the constant is, because on this second fundamental theorem of calculus, you're taking the derivative of something that's going to be 0 because it's going to be a constant. So all you care about is where the variables are. All right. And so in this case, f prime, big F prime of x was not. It was not. It was missing the chain rule. Was not f of x. Okay, so we needed to have a chain rule on top of that. All right, same thing if you flipped them around. All right, so you can do this any way you want, but I'll continue like we did a second ago. So we're going from, and let's say this time it's correct, function of x on the bottom, yeah, function x on top. They both are. All right, so what's happening on this one is same thing as before, but we're going to need 2 chain rules. We're going to need one for the top and one for the bottom, okay, because once we get to that point. All right, so here we go. So I've got f. Let me switch to this. I think this goes a little bit better. All right, good. Yeah. So f of x, yeah, much nicer, is equal to the antiderivative of sine, which is going to be negative cosine t, all right, evaluated from x squared to cosine x. All right, so that's going to equal, we're just substituting in, we're going to have negative cosine x okay, minus, this is fundamental theorem of calculus, I'll put in parentheses there, negative cosine x squared. Cool. Okay, now we're supposed to take the derivative of that, and you can see what's about to happen. So we've got f prime of x is going to equal, all right, derivative of negative cosine is sine. So that's all nice. Okay, but then, oh no, we had to copy in this cosine x. Oh, wow. And then, since that was an x, we needed to take the derivative of that. Chain rule. All right, so derivative of cosine is negative sine. All right, minus. All right, the antiderivative of, sorry. The derivative of negative cosine is sine. We already did the antiderivative. Copy. Chain rule. All right, so obviously that's not just equal to the sine of cosine x, right? That part's there, minus the sine of x squared. That part's there. Both of them required a chain rule. So we needed a chain rule on both of them. So once again, f prime of x is not equal to f of x, but in this case, those two substituted in, right? So that's really what we should say. It's not. All right, now what we should see though, and we won't ever have to go through all this mess again, is you're substituting in the x cubed. So the actual derivative here is you substitute the x cubed. Let me show right here. We put x cubed right there in for t, right? Same everything because we're doing the derivative of an antiderivative. So all this 1/2, we didn't have to go through the 3/2 and the 2/3 and all that stuff. That's just going in circles. But one thing that was needed was a chain rule. All right, so these can be really, really fast. But if you don't realize that you need a chain rule on these, then you can end up missing them. All right, so it gets a little crazy. I like the explanation, but the thing is, if you're going from a constant to x, yeah, just throw x in there and you're done because the chain rule of x is 1. But if you're going from a constant to something other than x, it's chain rule just like it always was. Nothing new there.